No, copy paste.
She didn't make it rip it out.
Star essay. Star essay. 600. I'm gonna make mine in the point of view of Chewbacca. When a Groot. I'm Groot. I'm Groot. I'm Groot. I'm Groot.
Hello, Garmin.
Why'd you break my chair?
What about the chair?
Ryan, you need to leave.
Spring, are you gonna start it?
I think Spring's gonna play.
I know.
Please. Guys, I think I'm winning this DR.
I'll go start.
You did not have such a assignment as that.
We had I.
I know please. Continuing our discussion of conjunction junction, what's your function? Bringing up verbs and nouns, a little extra piece of something special. Ages of snowflakes, gonna mess up with your concentration.
Never.
What was it that we just learned? What was the accent about? Oh, domain and range. Domain, range, input, output. Today, ladies and gents, we have like 6 more things to learn about things here. Mark, if you don't want to be here, you can go out in the hall.
Just tired. You need to.
I don't care whether you're tired or not. You will like this class, you will enjoy it. It will be your favorite of all.
I love this.
That's what I thought.
Who said it was?
That's what I thought. I suppose this would be more helpful if I erased it. Those of you tuning in on home, this will be lots of fun. I am trying to record this. Oh! I best a bird!
Say like this.
I'm going to get so much homework.
Hi,
It's not even gonna be fun. I best a bird.
Who's our gosh?
Not a cat.
Yeah.
Who's the bird?
Who's our yeah.
No, not cat. Not cat or say.
God.
Who's the
Yeah.
I gotta get rid of this because I
Yeah.
need a clean slate here. Now, let's just review for all intents and purposes.
Let's go.
Should have been more prepared for this.
So close.
Let's just talk about this for a minute.
Oh!
What's it called?
It was really close.
It was written down.
Remember this again, let's not forget about domain and range though. This is a quick little review here. First of all, let me just do this here. If I said y equals 2x plus 4, and we graphed that line. Back in the day, in 7th grade, David, you guys could graph this by slope-intercept form, right? Does anybody remember those words?
Yeah.
Not gonna worry about that. I'm gonna do this. I'm gonna make x and y values. Remember, x was the domain. Also, the input numbers. Y is the range. Also, the output number. Input is the independent ones. And output is the dependent one, because y depends on what you put in for x. We don't pick y values and get our x, although we could if we wanted to solve it that way. You put the x's in and y depends on that. That's why this is the dependent and this is the independent. So here I go. I'm going to put a 0, I'm going to put a -1, I'm going to put a 2, and I'm going to put a -3 in there. Quickly doing the math, if I put 0 in for x, 2 times 0 is 0 plus 4 is 4. If I put a -1 in for x, 2 times -1 is -2 plus 4 is 2. Tell me if that's going too fast. I get 8, and I get what? Somebody do that. Put -3 in for that. -2. Thank you. And then I can graph those points. Here is 0, 4. Here is -1, 2. Here is 2, 8. here is -3, -2. I get this nice straight line if I would have actually done it there, right? That's kind of where we're going with all this sort of thing. Here's something we didn't talk about, but I want you to think about. Something we didn't talk about, I want you to think about. If I asked you to give me the domain of this line, first of all, remember, these points are part of the domain, but they're not the whole domain. What would the domain be? How far on X do we go right and left? Far?
-3 to 2.
Wait, where -3 is right here. This line goes past -3.
Oh, would be
Oh, listen to this guy go.
X is greater than -3, but wait, no. X is less than -3.
Now, what I want you to do, what do these arrows mean here, Lila Francischini? What do these arrows mean? What do the arrows on the end of a line mean? Emily Robbins?
They go on forever.
Goes on forever. So let me ask you a question. Could I have would one of my domain values, could it be -7? Yes or no?
Yes.
Yes, because I could keep going 4, 5, 6, -7 would come down here. Could it be -300?
Yes.
Could it be +300?
Yes.
Yes.
What is my domain actually going to be? Tell me something it can't be. David, give it to me.
-2.
Here's X is -2 right there, it's on the line.
Oh.
I mean, it can't be that, it can be that. Ladies and gentlemen, the domain in this particular graph is all real numbers. It's infinity. Well, I put all real numbers. Because it goes forever this way. There's not a number you can tell me for X that's not, it won't be on that line somewhere. This goes on forever. Now, Y, on the other hand, what is the range? What Y values? Chris Anderson, this is where you come in. Give me a Y value that it can't be, please.
There is none.
There is none. So guess what Y is?
All real numbers.
All real numbers as well. If you get a straight line that has arrows over it, the domain and the range are always going to be all real numbers. Congratulations, you've now learned something very special. Even if it looked like, now this, hold on, let me give you another, just because we're on some sort of roll. Let's say this was my graph, and this was my graph. First of all, is that a function, yes or no?
Yes.
Y?
Vertical.
Vertical line. Why are you shaking your head, Connor? Now this one, by the way, this has nothing to do with what we're doing for today, but I thought it was a good tie-in. This one, what is my domain? Who thinks they have the answer there? Conrad, Mr. Miss Headshaker, what is my domain? Give me an X value that I can't have. Anybody? Emma Martin? What's my domain? Tell me something X can't be. Let's say this was -1, -2, -3, -4, -5, -6, -7. Can X be -7? It will eventually. This thing might keep going up, but eventually it's going to get to -7. And eventually it's going to get to every number. My domain is all real numbers. What's your point, you're asking? This one, though, the range is not. Will you ever get any of these negative values here? No, because it goes forever upwards there. So you can define a certain range. What would that range be?
0.
0 to infinity, which actually would be this. The range would be Y is anything greater than 0. Or if, I like the way you were thinking, you could actually write it out as 0 to infinity. Y has to be. Although, can you equal infinity? Does anybody know what equal is? All right, now take out this. Forget it. That was just a lead in here. When we talk about functions or just simply graphs of line, children, here are some phrases you need to know. Okay? They are the x-intercept and the y-intercept, and I think we even talked about this last year, didn't we?
Yes.
Did we not graph equations in standard form? You don't remember because you weren't paying attention. Some of you might have been sleeping. What is the x-intercept? Simply where the graph intersects the y or the x-axis. X-intercept is where the graph, where the line crosses the x-axis. The x-intercept is right here. And I don't know what that number is because it doesn't just says that, right? But it's important to note, ladies and gentlemen, it is important to note that at that particular point, where it crosses the x-axis, y will be 0. The y value, because y is 0 right there, wherever it crosses, y is going to be 0. At this point, whatever it is always going to be like 6, 0. That y will always be 0 at the x-intercept. And the converse, or the same thing, or whatever is true with the y-intercept. The y-intercept is where it crosses the y-axis. And it is where x equals 0. Because here's the y-axis. X is going to be 0 at that point. You with me? Let's look at said example. Am I the one that's excited about this? What is my x-intercept? Well, look at the x-axis. Where does this line cross the x-axis? Liam Bocek?
-2.
At -2. What is my y value always at the x-intercept? 0. That point will be -2, 0. The y-intercept, children, where does it cross the y-axis, David?
4.
What is my x value at the y-intercept? 0. So 0, 4 is the y-intercept, and -2, 0 is the x-intercept. Intercepts are really pretty simple, just where they cross, where they intersect. Oh, thank you for that. I infest the bird, ladies and gentlemen. Okay, now a couple other terms that the book, by the way, this is the first time I've actually, that makes sense, but I've never actually taught this particular thing about these things today. Why not? It actually makes a little bit of sense. All right, we have positive parts of the function and negative parts. If it is positive, they are always talking about with regard to the x-axis. Positive. Positive is above the x-axis. So any part that falls in the graph up here, that's 2, 3. Any part of the graph that falls up there is where the graph is positive. Any part below the negative falls below the x-axis. Don't worry about the y parts. Okay, so if it is below, that's the negative part of the graph. Negative and positive. Same thing kind of here. The important thing about this, if somebody asks you, is the graph increasing or decreasing, it's a lot like slope. If it's positive slope, it's increasing. If it's negative slope, it's decreasing. You have to look at the graph from left to right. Otherwise, it won't make much sense to you. From left to right. So here, that's why this. See what they have in blue? Because the graph from left to right, this is going up. That is the increasing part. But then the red part, it starts to go down, so it's decreasing. And then the blue, it goes back to increasing. From left to right. Increases, decreases, increases. Who? Okay. And then the end behavior of a function, that just means what's happening, what happens at the end of the graph. Okay, and because this arrow is here, that's why they put this little infinity sign. This graph goes on for infinity. It's increasing as it goes off to infinity. This one is decreasing as it goes off to infinity, but the end is that sort of thing there. So wait, what was my question down here? I wanted a question there.
Was that graph increasing?
Where, so let's go with part number one. Which part of this graph would be in the positive section? Positive section is right here. So these parts right here are in the positive section. What part are in the negative section? That's the part that's below the x-axis. Okay. What part is increasing? So from here to here is increasing. So I suppose should I go with the same colors they had? Here to here it increases, right? And when it gets to the top, it decreases till it gets there. Then it increases till it gets there.
Interesting.
And then the same thing is true for this. Both the x and the y, what's the end behavior of these? They're both going off to infinity, both for x and for y. Now, with that being said, open your books, let's see if any of this is gonna make sense down to whatever. What page was it?
160.
100. What number?
100.
Oh, wait, I thought I had some questions here. I might have, but wait, let's go back to it here. Hold on. Well, maybe not. Sure, look at page 120. I wish I had these up on the screen. Is there a way I could get them up there real fast? Wait a minute. What's the beauty of the bicameral system? What? Who said something? What's going on here? Watch this. Can I do this? Back in the day, this would never have worked. What? Let's look at problem number 1. 5, 4, 3, 2, 1. Oh, copy, hold on a second. I just emailed myself a whole bunch of stuff. Make that amazing.
Yeah.
Problem number 1.
Never back
It's what?
Amy.
I'll put number 1 and number 2 up there.
There we go.
And if I go back to this,
Let's go.
can I put number 1 and number 2? You can ooh and ah all you want.
Ooh.
Alright, so the question on this one, problem number 1 here is, what are the x and the y intercepts? Estimate the intercepts. They say estimate, but they give you well, you do have to. This first one here, where would the x-intercept be here? Who wants it? Spring! Where does this line cross the x-axis? That's why it's an estimation. Cross was right here. What is that point? Well, it's 1.5, wasn't it? So the x-intercept is 1.5 comma 0, correct? Yes. How about the y? Reagan Grider, where does it cross the y-axis? Y equals 0 comma 3, because that's where x is 0. Are you with me? That point there is 0, 3. That point there is 1.5 comma 0. Ooh, how about this one? Wait, okay, this is, by the way, that's kind of confusing, but this is the x-axis. What is the what's the x-intercept? Where does it cross the x-axis? Ryan? Come on, sir, you got this. Ryan, does it cross the x-axis?
No.
No, there is no x-intercept. Ryan, what's the y-intercept?
Negative 2.5.
Yeah, look at it.
How do you know that?
x at that point? Zero. There's my line.
Yay.
What, looking at the third one in your book there? Ooh,
Yeah.
how about the y-intercept? What's the y-intercept for problem number 3? Emily Robbins, looking at problem number 3 on page 120 on the very bottom, where does that cross the y-axis?
0.
Correct, 0. How about the x-axis, Christopher Anderson?
Negative 1. 0.
I think it's -1 and +1, isn't it? There's 2 of them, and they're both at 0, are they not?
Yeah, they both are.
Are they both in? All right, now look at the next page. Guess what? I'm going to slap this one up. Send it to myself again. How many of you are very excited about this?
Me.
So you can see it. Now, the next 5, 6, and 7 get a little more complicated, ladies and gentlemen, in that. I should have done this way before. Uh-oh. Sorry, kids. I apologize for my incompetence. Look at what you're asked to find here. Ooh, you are asked to find what? 4 things. What does it say? You are supposed to find, approximate when is the function positive? Think about this. When is it positive? When is it negative? When is it increasing and when is it decreasing? So, first of all, when is it positive? What's positive mean? It's the top half of this. So when does this positive thing happen? When what? What? At 2. It's positive when x is greater than 2, correct? Because if you keep getting over here, it keeps going over there. When is it negative based on that, Anderson?
It's less than 2.
When x is less than -2. Or less than 2, sorry. When is it increasing? So the question would be, Anna Weiss, when is it decreasing? Now, remember, Anna, decreasing means from left to right, it has to be going downhill. At what point does this line go downhill? Huh? Never, right? So, when is it increasing? All real numbers. When is it decreasing? Never. Wait, did it ask something else? Oh, then what do the endpoints do? Go on forever to infinity. Goes infinity in both directions. Ooh, now let's try this one. I'll let you jot down what you think your answers to this would be. Because at some point you gotta try for yourself. When is it positive, Spring? When is it negative? When is it decreasing? And when is it increasing? This actually should have answers for all of them. Write down your answers in mathematical jargon. See what you can come up with that. When is it increasing, decreasing? See if yours match up with mine. See if you and me and a dog named Boo and a cat named Kalamazoo all match up. This is so much more fun than 6th grade math. Well, we've got people that are done. Kabarak is already bored with all this. You make a good math teacher. How's Rev doing? You never talked to me.
I mean, I did.
You guys get into a, what, not sound drag out fight? Really?
He says school's actually hard for him.
It's actually hard?
He says junior year is free.
Ooh,
DPC.
good. Good. All right, I ain't got all day on this, so we gotta move on so we can move on here. Avery Heron. Question on the floor is, when is this graph positive? When does it become positive? What's that? 0 and 2, yeah. When x is 0 and when x is 2. If you want to put the y values there, you can put that there. They both be 0. At 0, 0, and at 2, 0. Y'all get that? Because right here, the graph is only positive right here when this goes in, which means when is it negative? Here's where we get to use our compound inequalities. When x is what? Who thinks it? Carter Reichert? When is it negative?
4.
What's that?
-1.
Right, but how am I gonna say it? It's negative. It is negative from here to here. How do I write that out mathematically so somebody knows what that is?
-1 here.
Oh, I'm sorry. I needed to do this over here. This had to be when x, sorry. We needed to write this out. It is positive when x is what? Less than 0. Because at here, it starts going this way. Anything here is going to be positive. And over here, it would be when x is greater than 2, correct? Not just not equal to there, it's just when it's greater than that. Which means it's below that when x is between 0 and 2. How do we write that out mathematically? Between 0 and 2 when x is that. X is greater than 0 and less than 2 inequalities. That's that little chunk right there. X is greater than 0 but less than 2. Are you working? Are you feeling it? Is that making some sense? How about increase? When is this thing increasing? Ooh, how am I going to describe that? Because when does it decrease? From left to right, this thing decreases like till it gets to right here. How do I show that, or how can I tell somebody that? You know it stops decreasing at what point?
-1. 1, -1.
Yeah, it stops decreasing there, but we're only talking about the x-axis, I believe. When does it stop decreasing? Where's my increasing thing? Mark, what are you saying?
It starts increasing at 1, -1.
All right, so increasing is where x is what? Greater than 1, correct? And decreasing is when x is
Less.
less than 1. Because anything less than 1, it's decreasing. And then what are the endpoints? Infinity this way, infinity that way. And you're all, that's what keeps going. X is infinity. What is the y endpoint? On the bottom, it starts here, but it starts at -1 and goes to 0. That makes some sort of sense? A little sense? No sense? Speak forever. All right, now I told you, I promised you yesterday that we would do, your assignment is 2 parts. We do have the end of the day here, so don't. I got this worksheet for you to do, which is only 9 problems. But page 118, as a review, because you will forget everything you know right now. What's that? Page 118, problem 42 through 62, what is that, 21? 42 through 62. I think there's one I didn't want you to do. I'm trying to think what it is. You know, I just do 62, don't do 62. There's 20 there and 9 there, so grand total of 29. We have 20 minutes now, 40 minutes at the end of the day. You may or may not have a question. You might want to start on the worksheet first, just so you can ask. And the first one should be, first 4 should be easy here. All of that is what it intercepts. But you can write your answers down. Thank you for all those. Oh, no, don't say it just because.